The amount of water used daily by each American has a standard deviation of 10 gallons. You take a sample of 29 people and find that the average amount of water they use each day is 86 gallons. Find a 95% confidence interval estimate of the average amount of water used each day by the typical American. So one of the steps to these would be, first of all, identifying what is X bar, what is N. We also want to know sigma if we can find it. So let's see, X bar. Right here. The average amount of water that your sample uses, your 29 people use 86 gallons. N is going to be 29. That's the number of people that we sampled. The standard deviation is claimed to be 10 gallons for all Americans. So that is a population standard deviation that they're talking about. So that's sigma. All right, now we have to find what's called the margin of error. And the way we find the margin of error is through a formula here, ZC times sigma over the square root of N. Now we know the sigma, we know the N, but we do have to find the ZC. So let's draw a curve for a 95% confidence interval. So we want 95% of the area to be in the middle. That means that each tail is going to have an area of 0.025. We need to find out what Z's correspond to those tails. So you can do that with the formula sheets or stattrack.com or TI calculator. All right, we're going to want to find the Z that goes along with that left tail of 0.025. So if we just go to second distribution, go to inverse normal, choice 3. We'll put in an area of 0.025 for the left tail. That's one option, and that'll give you your answer. So our Z is negative 1.96 approximately here. And by symmetry, this one will be positive 1.96. An alternative way of doing it, though, would be to put in the confidence level, 0.95, and then we'll go to center, and that can give you the ZCs as well. Alright, so now we got the ZCs, and we're ready to calculate the margin of error. So we'll just plug in 1.96, our sigma of 10 gallons. We'll divide by the square root of 29. I get 3.64. Now, if you didn't have the access to the TI-84, you could use StatTrak just as easily to get that Z. Alright, in StatTrak, we'll go to continuous probability distribution. We'll go to normal distribution. For your cumulative probability, put a 0.025, which is the area of the tail. Hit calculate, and that's a way we can get the negative 1.96. Yet another way would be to go to the formula sheets. If we use the formula sheets, we can look for a left tail of 0.025. We got to locate that in the body of the table here because these are the areas. Right here is 0.025, and so as we can see, that does occur at the intersection of negative 1.9 and 6 hundredths. So we're looking for a z of negative 1.96. Alright, once we have the margin of error, we can go on to construct the confidence interval. We'll put the x bar in the middle. So the x bar was 86 gallons. That was our sample mean. We'll assume that our sample mean is the best estimate of the true population mean. But we'll say that, we'll acknowledge that we could be wrong. We could be off by as much as 3.64 gallons for a 95% confidence interval. So over here we want to do x bar plus e, and then over here we'll do x bar minus e. So we just want to do 86 plus 3.64 and then 86 minus 3.64. I get 89.64 gallons and 82.36 gallons. And we'll say now that we are 95% confident that the true population mean amount of water used by Americans on average is between 82.36 and 89.64 gallons.